Okay, this video is a continuation of our study on complex polynomial equations. In the previous video, we looked at how to solve quadratic equations that involve complex roots. Here we are going to take the study further, and we're going to look at higher degree polynomial equations. So in particular, we're going to look at equations of degree 3 and 4. But in this study, we are just going to focus on those equations that can be solved directly. So by directly, we mean without the use of the rational root theorem in the rational root theorem. In the next video, which is going to be part 5, then we're going to look at equations where you have to use the rational root theorem. But in this case, we're looking at equations that you can solve directly, and there are two classes of those equations. First, it's equations of degree 4 where only even powers appear in the equation. So those ones we can solve directly. Actually, these ones we solve like quadratics. We're going to demonstrate how this works out. And then equations where only one term involves the unknown. For instance, this is a cubic, but there's only one z term. This is fourth degree, there's only one z term. So those equations, we can find the solutions directly. So let's get on with the first example. So in the first example, we've got z squared, z to the power 4 minus 3z squared minus 4 is equal to 0. So here only the even powers appear. So what we can do here is we can let z squared be equal to a new variable, say u. Then from this, u squared is going to be z to the power 4. So that means this equation is going to become u squared minus 3u minus 4, which is quadratic. So this now we can factorize. So this is going to be u minus 4 times u plus 1. And then if we recall that actually u is z squared, so we can write this as u squared, z squared minus 4 into z squared plus 1. At this point, this implies that either z squared minus 4 is equals to 0, or z squared plus 1 is equal to 0. From z squared minus 4 equals to 0, it means z squared is 4. This side, z squared is negative 1. So here, z is going to be plus or minus the square root of 4. So that's going to be plus or minus 2. Here, z is going to be plus or minus the square root of negative 1. So it's going to be plus or minus I. So that means the roots of our equation, in summary, are plus or minus 2, plus or minus I. So that is the first example. In the second example, in part B, we have got z cubed plus I is equals to 0. So here this is a cubic, but the unknown appears only once. So here we're going to seek to make z the subject of the formula. So at this point, we can see that z is going to be the cube root of negative I. So then we can find these using the de Moivre's theorem, which you can check in our video on roots. We're going to just put the link just here. So all we need to do here is to write negative I in polar form, and then we're going to bring it back here, plug it into that. So negative I in coordinate form is 0, -1. So if we make a sketch, if we plot it on the Argand diagram, it's going to be located there. This distance is 1, so that means r is 1. This angle here is -pi/2, or -90. So that's going to be, so that means negative I we can write in exponential form as e to the I -pi/2 plus 2 pi k, where k is an integer. Okay, by the way, this is equivalent to that, so we can use either of those two formulations. So now remember, z is the cube root of that. So going back to z, so 1/3 here. So this is going to be CIS -pi/2 plus 2 pi k, all raised to the power 1/3. Then by de Moivre's, we are going to multiply these by 1/3. So it's going to be -pi/6 plus 2 pi k over 3. At this point, I'm going to denote this zk. So then we just choose values of k and get our 3 roots. When k is 0, for instance, this is simply going to be CIS minus pi/6. So CIS minus pi/6 is cosine minus pi/6 plus I sine minus pi/6, which we can punch in the calculator. So if you just make sure that our calculator is in the radians mode, then we can do cosine negative pi/6. So there is pi/6 on 6, not -6, cosine negative pi/6. So that is point or square root 3/2. Then we do the sign of negative pi/6. So negative pi divided by 6, and that one is 1/2. So that means this root we can write as 1/2 into root 3 minus I. So that is the first root. There is going to be 2 more. So the second one, when k is equal to 1 here, so we're going to denote it z1. So that's going to be CIS minus pi/6 plus 2 pi/3. And so 2/3 minus 1/6 is just going to be it's going to be 3 pi over 6, which is pi over 2. So then cosine pi on 2 is going to be 0. So let's just confirm that. Cosine pi on 2 is 0. And then on the other hand, sine pi on 2 is going to be 1. So that means this is going to be 0 plus I times 1. So this is equal to I. So that is going to be our second root. Then the third one, when z is equal, k is equal to 2, we're going to have cis minus pi on 6 plus 4 pi on 3. Okay, now 4 pi on 3 minus 1 on 6 is going to work out to 7 pi over 6. So this time we do cosine 7 pi on 6 and sine 7 pi on 6. So 7 pi, 7, not 4. So 7 pi on 6. So that is negative root 3 on 2. And then sine 7 pi on 6 is negative 1/2. So this is going to be 1/2, negative 1/2 into root 3 plus I. So in summary, the three roots of the equation are 1/2 into root 3 minus I. The second root is I. The third root is minus 1/2 into root 3 plus I. The second one is pretty easy to prove that it is a solution. So let's just do that. So our equation is z cubed plus I equal to 0. So if you plug in z is I, this is going to be I cubed plus I. So just working on the left hand side. If you factorize I here, this is I into I squared plus 1. But we know that I squared is negative 1. So this is I times 0. This is equals to 0, which is the same as the right hand side. So that shows us that indeed I is a root of our equation. All right. In the next question, we have z to the power 4 plus 16 is equal to 0. So the way we're going to solve this is pretty similar to what we did in part B. We're just going to make the z the subject of the formula. So z to the power 4 here is negative 16. Then we're going to take the roots of that, the fourth roots, that is, so negative 16 to the power 1 over 4. So what we need to do is to write negative 16 in polar form. So negative 16 is going to be located there. This distance is 16. So R is 16. This angle is 180 or pi radians. So what this means is that negative 16 can be written as 16 cis pi and then plus 2 pi k. Then if we take this and plug it in here, then our z is going to be equal to 16 cis pi plus 2 pi k raised to the power 1 over 4. The modulus we raise to the power 1 over 4. The argument we multiply by 1 over 4. So it's going to be over 4 there. So again, if we now denote these z sub k, 16 to the power 4 is 2. So it's going to be cis pi over 4 plus pi over 2k. And then we just plug in values of k starting from 0. When k is 0, this is going to give us cis pi on 4. Now, cosine pi on 4 is 1 over root 2. So this is going to be 1 over root 2 here. Sine pi on 4 is exactly the same. So if we factor out the root 2, then there's going to be 2 over root 2 into 1 plus I. But 2 over root 2 is square root 2. So we can write that first root as square root 2 into 1 plus I. Then when k is equal to 1, there's going to be 2 times cis pi over 4 plus pi over 2. So this is going to be cis 3 pi over 4. So that's an angle in the second quadrant, 135 degrees. So this time the cosine is going to be negative. Otherwise the values are going to be the same as these ones here. All that's going to happen is it's the sign that's going to change, because what we're having is this situation. This is pi on 4, then the next one is here 3 pi on 4, but both of them have got the same reference. So then this is going to be I over root 2. So that means this one is going to work out to root 2 into minus 1 plus I. Then when k is 2, so going back to our formula here, when k is 2, so that formula is going to give us 2 cis pi on 2, well, it's actually pi on 4, plus pi. So this time is going to be 2 cis 5 pi on 4. So we are now going to be in the third quadrant. The same values for the cosine and sine, but the only difference is that they are both going to be negative. So if we work this thing out, we're going to have negative root 2 into 1 plus I. And then finally, when k is 3, it's going to be 2 times cis pi over 4 plus 3 pi over 2. So this is going to be 2 times cis 7 pi over 4. And this time the cosine is going to be positive and the sine is going to be negative. So that's going to be the 4 roots. So we can summarize. So the roots are going to be plus or minus root 2, 1 plus I, and then plus or minus root 2, 1 minus I. Okay. So at this point, we're going to give you an opportunity to have a go at the 3 remaining equations. D, E and F. So if you just want to pause the video, work through these three, then when you continue the video, you can compare your solutions with what will be our solutions. All right. So we're now going to scroll down to our solutions for D, E, and F. By the way, we'd like to thank you for visiting our channel and watching this video. We do hope that you find the material useful. Please, we do implore you to subscribe to our channel and like the video. If you've got any questions, you can post them in the comment section. So for D, then Z appears only once, so that means you can make Z the subject of the formula. Then after that, we write this in polar form. It's going to take this form. So the R is 8, and because the number is going to be located like that, this distance is 8, and this angle is pi. And so where k is an integer here, so when k is 0, this thing gives us this, which works out to 1 plus I root 3. When k is 1, then we've got 2 cis pi, just works out to -2. When k is 2, works out to 2 cis 5 pound 3, and that works out to 1 minus I. For F, we have got a 4th degree polynomial, but only the even powers appear, so we can treat it as a quadratic. And so indeed we factorize it like this. It's a quadratic in z squared. So from here we've got z squared plus 9 is 0, so z is plus or minus 3i. From here z squared minus 4 is 0, so z is plus or minus 2. It looks like we skipped D. D is 4th degree, z appears once, but we also notice that this is a difference of 2 squares. So if you like, it behaves like a quadratic because you only got power 4 and power 0. So we factorize it using difference of 2 squares approach. So then either z is plus or minus 3 or z is plus or minus 3i. All right, thank you.